So for decades, this was the master plan: chain clever filters together by hand into a pipeline. First, find the edges. Then group nearby edges into corners and blobs. Then describe the pattern of those corners around each interesting point and turn it into a compact signature. Famous, brilliant methods did exactly this. You may hear their names: SIFT and HOG. They were carefully engineered features, designed by very smart people over many years. And for a while, they genuinely worked. They gave us panorama stitching on our cameras, the first face detectors in point-and-shoot cameras, early object recognition. SIFT, for instance, was genuinely clever. It found keypoints that survived zooming and rotation, so you could match the same object across different photos. People even built early image search this way, by collecting an image's features into a bag of visual words. But this whole approach slammed into a hard ceiling. A feature hand-tuned to recognize a cat in bright daylight would simply fail at night. Change the camera angle, change the lighting, add a cluttered background or a partly hidden object, and the careful pipeline would crumble. The problem was fundamental. The real world has far too much variety to ever cover with handwritten rules. Engineers would spend years crafting features for one narrow problem and end up with something brittle that broke the moment conditions shifted. It was clear the field needed a completely different idea. Not humans painstakingly designing features, but a system that could learn the right features by itself, directly from examples. That idea is the deep learning revolution, and it begins right now.